Yo guys, what's up, what's up? We are live, we are live, we are live, we are live right now. We have just gone live right now. Right now, right now. Yo guys, what's up, what's up? Okay boys, it's time to start the stream, let's get it.
Over, you just can't breathe. Do you feel your bones start to shake? Do you feel the earthquake? Do you feel your bones start to shake? Do you feel the earthquake? Do you feel your bones start to shake? Do you feel the earthquake? Do you feel your bones start to shake? Do you feel the earthquake?
Alright y'all. Okay boys. Alright y'all boys, man. So okay, I got kinda guessed from that. Okay. So the game plan for today is the following. So I have prepared 8 problems for y'all boys, okay? I've prepared 8 problems for y'all boys. Now, we're going to be going through these problems and I'm gonna be breaking down each one of them. So we're gonna go into the solution, maybe the time and space complexity as well. And that's gonna be it. So the stream is either gonna end when I go through all of these 8 problems, or when we hit the 1 hour mark. So the stream is going to end either when I go through all these problems or when we hit the 1 hour mark. As we can see, we got 1, 2, 3, 4 code forces problems, and we got 1, 2, 3, 4 lead code problems. Okay, so let's start going through these. Okay, I think the subscribe thing is a little too big. Let's make it a little smaller. Alright y'all, so without further ado, let's start. So we're gonna go first to our first problem, which is Code Forces 1760A medium number. So let's go. Okay, medium number. This one is 800 rated. The tags are implementation and sortings. So the statement is the following. Given 3 distinct integers a, b, and c, find the medium number between all of them. The medium number is the number that is neither the minimum nor the maximum of the given 3 numbers. For example, the medium of 5 to 6 is 5. So we want neither the minimum or maximum. So the minimum is 2, the maximum is 6. And the medium is 5 because it's neither the minimum or the maximum. So we return 5. And these are distinct numbers, so we don't gotta worry about weird cases where there's 2 numbers which are the same and things like that. Since the minimum number is 2 and the maximum is 6, we print 5. Okay, so first we have our test cases. So if you guys have never seen a competitive programming style question before, basically these test cases, we are gonna get this number and then we are gonna basically run a for loop from for this many iterations, and on each iteration we are going to perform the solution. And as you can see, this is the solution for iteration 1 is this. Then we get data in the second iteration, we get data in the third iteration, print the solution for that iteration, and so on. Alright, so that's how that works. Okay, so from this input, how do we get this output? Well, we have 5, 2, and 6. We want the medium, so that is the number which is neither the smallest or the biggest. The smallest number is 2, the biggest number is 6, so we print 5. Next we have 14, 3, and 4. The smallest number is 3, the biggest number is 14, so we print 4, and here we get 4. Next we get 22 and 1. The smallest number is 1, the biggest is 20, so we get 2 right there. Then 1, 2, and 3, 2 again because 2 is the medium. Then 11, 19, and 12, we're gonna print 12 because 12 is neither the smallest or biggest number. Okay, so there are a couple ways in which we can solve this. Okay, so right now let's get the problem statement and let's paste it here into Paint. Let's paste it here into Paint, make it smaller, something like that. Okay, it kinda got messed up. What to do? Okay, so okay guys, so I basically went over how to, so we can use, to solve this, we can either use a bunch of if statements, or since we can see from the tag sortings, we can sort the array in we can sort the array. I mean, this is not, we can put all of these numbers in an array. So, and here we're gonna say code. So we're gonna say problem code forces this. Okay, and let's make it okay. So that's the problem. Code forces medium number. So we have A, B, and C. This is our input, and we get basically print number which is neither biggest or smallest, medium. Okay, so this is basically what we have to do. Okay, and this text is too big. So out of these three numbers, we have to print the number which is neither biggest nor smallest. Okay guys, that's what we have to do. That is what we have to do. So how do we do this? Well, we could use a bunch of if statements, but I think a cleaner approach, we can use a bunch of if statements, and I think that would be faster, because if statements are all of one time complexity. But the way that I solve this is by doing the following. So approach. So the approach I did is push A, B, and okay, let's not make it bold. Push A, B, and C. Let's make a comma into array, then sort the array and print middle number or array of 1. Okay, So this is the approach. Push A, B, and C into array, then print, then sort the array and print middle number. And while solving this, while trying to solve this with while I tried first to solve this with if statements, but I got confused, and this was more intuitive to me, for me. So now in this case, we only have three numbers. So we can see that the time limit is 1 second, and here we only have three numbers. On each test case, we have only three numbers. So the time complexity because of sorting will be O of n log n, and that is how much optimal sorting algorithms take. They take O of n log n. So in this case, we have 3 always. So time complexity is O of 3 log of 3. Okay, this is the time complexity. And let's say we get the numbers. So in case 1, let's see what they equal to. So they are 5, 2, and 6. 5, 2, and 6. And we get 5. Okay. In case 1, A equals 5, B equals 2, C equals 6. And then we're going to put them inside of an array. So we're gonna make an array, and this is gonna be with 5, 2, and 6. So first we get the input, then we push all the numbers inside of an array, and finally we sort the array, for which I have used a built-in sort function. Guys, it is important when you have to sort an array, or when you have to use some sort of algorithm. For example, when you have to find the greatest common divisor or something like that, if there is a built-in function in your programming language for that, do not write the algorithm from scratch, because first of all, you may get confused, and second of all, you may not write it correctly. And when you are inside of a contest or in a coding interview, speed is of key. Speed is key when you are inside of a contest or a coding interview. So make sure, this is important. So let's write it with red. Make sure to always use inbuilt functions for sorting, etc. For sorting, GCD, etc. if they are present in your coding language of choice. Okay, of choice. All right, we're gonna put this here, and we're gonna do this, something like this. Okay, so make sure to always use inbuilt functions for sorting, greatest common divisor, etc. So inside of C++ there is a sorting function, and inside of Python there is also a sorting function. I'm pretty sure that inside JavaScript there's also a sorting function as well. So yeah, if there is an inbuilt function for the algorithm, make sure to use that, so you don't lose time and you don't get confused and stuck. Okay, so then so first we get the input, then we put it in the array, then we sort the array, and then array after is going to be after, I'm writing in after, okay, it's gonna be right this word. After sorting array is equal to 2, 5, 6. And we can see, and guys, we can see that the first element at index number 1, is actually our answer. So answer is equal to array of 1. And this is always the case. This is always the case. After we have put, since there are we get 3 distinct integers. So answer will, when we push them inside of an array and we sort the array, the answer is always going to be equal to the array of 1, which in this case is 5. So in case 1 is 5. Okay. All right. Okay, so let's look at another test case. So the second case is this one. So for a second case is this: A is 14, B is 3, and C is 4. So case 2, A is 14, B is 3, and C is 4, or was it something else? Yeah. Okay. So the answer here is going to be 4. So first we're going to push all the elements inside of an array. So 14, 3, and 4. Then we're gonna sort the array, and then the after sorting is going to be 3, 4, 14. Okay, and here the answer is array of 1, which is 4. Okay guys, the answer is array of 1, which is 4, and as we can see, the answer here is 4. And you do the same for all the other test cases. Okay, all right. Yeah, I think that that's pretty much okay. Let's make this a little bigger. Okay guys, and that's pretty much it for that. I think that's pretty much it for the first problem. Okay, that's it. So code forces 768 medium number is done and dusted. So we can mark this in what color? Maybe some sort of blue. Okay, so we did that one. Next is code forces 469A. I wanna be the guy. Okay, so this is going to be another code forces question. Oh, my bad, I didn't. What's your goal? I want to get. I don't really have a goal, man. I don't really have a goal. I just want to get good. I just want to get good at this stuff. I don't really have a goal. Okay, guys, so now I'm going to show you the code for this. But first, let me not dox my email, okay? Let me not dox my email first, and I'm gonna show you the code for this. If code forces loads today, that is. This is taking a long time to load. Bear with me, guys. Bear with me. Okay. Okay, it loaded, and cool. All the best. Thank you, man. Thank you so much. All the best for you too. Thank you so much. Okay, so the question was medium number. So we're gonna search here medium number. Here it is, and here's the code. So as we discussed, so we get our test cases. So while t minus minus, guys, if you don't know what this does, basically on each iteration, the value of t is going to decrement. So this is basically the same as t minus equals 1. And when t reaches 0, the loop will stop, and that is when we have exhausted all our test cases. And guys, please don't get intimidated by this C++ code. C++ is like any other programming language. When you have not seen it, it looks very difficult, but I promise you, once you learn it, it's not difficult at all. Okay, guys, and you don't need to use C++ for DSA. You can use JavaScript, you can use Python, you can use whatever you want, but I personally use C++. So what do we do? So first, as we talked, we have A, B, and C, which is our input, and this basically just takes A, B, and C for each test case. Then we're gonna make the array as we talked. We're gonna make an array. We're gonna push all of the numbers inside the array, so A, B, and C, and then we're going to sort the array just like we talked about here. First we're gonna push them in the array. So first push all the numbers into the array, then sort the array, and after sorting we're going to choose the array, the element at index 1 as the answer. Okay, and then we're just gonna what this does, it basically prints the element at index 1, and that is how we get our answer. Okay, and that's basically it for that one. I think that's basically it for that one. Okay, I think that one is okay. If you guys do have any questions while I'm explaining these, make sure to ask. It's not shameful to ask. Okay, now let's go to the second one, which is Code Forces 469A. I wanna be the guy. Let's go to this one. Okay, let's someone close this. I already have it. Okay, so this is the second problem. Let me just let me get rid of all of this. Okay, and now we're at this problem. So the tags are greedy. It's a greedy problem, and implementation means that the answer is hidden. Basically the problem statement is a little more like the answer is kind of hidden inside a problem statement. Okay, whatever. Yeah, so this is the next problem, and guys, the next problem is a lead code problem. So if you don't use Code Forces, just wait for a little bit. We're almost about to jump. We're gonna jump into 3 lead code problems in a row. Okay, we're just gonna go to this one, and then we're jumping into 3 lead code problems in a row. Okay, guys, so here's the statement. There's a game called I Wanna Be the Guy consisting of n levels. Okay, when you notice these, make sure, and n is actually, this is n, which is 4 right here. Little X and his friend Little Y are addicted to the game. Each of them wants to pass the whole game. Little X can pass only P levels of the game, and Little Y can pass only Q levels of the game. You are given the indices of the levels Little X can pass and the indices of levels Little Y can pass, where Little X and Y pass the whole game if they cooperate with each other. Okay, guys, I know the problem statement looks kind of weird, but don't get discouraged. All right, I'm gonna show you that this is not hard at all. So the first line contains an integer n, so this is the number of levels. Then we get P, which after we get P distinct integer. So this is P and this is also P. This is n, this is P, this is P. And then we get the levels X can pass. So this is the levels X can pass. So here we have 3, so we get 3 integers. Here we have 2, so we get 2 integers after this. Okay, so yeah, can pass, it's assumed levels are, okay, blah blah blah. Okay, we don't care about this. So what is the meat and bone of this? What is the approach here? So we want them to be able to pass the game together. So basically what we have to do, we have to find out if all of these numbers right here, when we put them together, do they go up to n, do they go up to n inclusive? Okay, so we can start from 1 because we can see 1 is here. All right, and so we have 1, 2, 3, and 2, 4. So basically all the distinct numbers are 1, 2, 3, and 4. So these numbers go all the way from 1 to 4. These numbers go all the way from 1 to 4. we have 1, 2, 3, and then we have 4. So we have all of the numbers from 1 to 4. 1, 2, 3, 4. And in this case, when all of the numbers from 1 until n are present, we are going to print I become the guy. So this is what we're gonna print. So if they can pass all the levels, together, means that these numbers and these numbers, when put together in some sort of structure or in some sort of queue, they need to be so the combination of all of these need to include all of the numbers from 1 to n. In this case, from 1 to 4, we have 1, 2, 3, and 4. So in this case, we print I become the guy. Now we have 4 again, but in this case, we print the false case, which is this, because we have 4 here, but we have only 1, 2, 3 right here and 2, 3. We do not have 4. We have only 1, 2, 3. The numbers only go from 1 to 3, not to 4. So we print the other answer. So it is said here as well. In the first sample, little s can pass levels 1, 2, and 3, and little y can pass 2 and 4. So they can pass all the levels both. All the levels are 4 here. So we have all the levels. They have passed all the levels 1, 2, 3, and 4. In the second sample, no one can pass level 4. Okay, guys, and that's basically what we need to figure out here. All right, and how do we solve this? What is the approach here? Well, the way that I solved it is I used a set data structure. So basically, a set data structure is in C++. It's something which it's like an array, but okay, let me get this. So we're gonna do current problem. We're gonna do this or something, and then we're gonna make it bigger like this. So this is the current problem. Okay, and how you open this program? Yeah, what's up, guys? Yeah, I know set is ordered and unique is sorted in unique, but I have to. I'm gonna go to I still haven't finished the whole explanation, so I'm gonna finish and then I'm gonna open the next problem. Okay, just have a little patience, guys. After this we are jumping into lead code problems. Okay, so yeah. So basically, as the guy in chat said, the set is sorted and unique. So basically, in C++, we have something known as a set data structure, which stores unique elements in strictly sorted order. Now, if you are using Python or like JavaScript or something, what you can do is before you add each next number, you can use an array, for example, in JavaScript, and before adding each next number, you can check if that number is already in the array, and if not, then just don't include it. Afterwards, when you have when you have an array of distinct integers, then you can just sort it and it will be basically the same thing. So basically, approach is store all numbers from 1 to n inclusive in data structure in increasing order, okay, without duplicates. Alright, guys, that is the approach. And let's say right here we have when n is, in this case, n is equal to, in this case, yes, I am a, hello sir, hello fearless, yes, I am a CS student. Okay, so we have all the numbers here, and then where was I? So we have them, okay, and we're gonna make a set in C++. So we're basically gonna set, and we're gonna have all the numbers like this. So in the first case, so case 1 is n is equal to 4, and then the input, then p is equal to okay, p first is equal to 3, and then okay, basically we're just gonna push all of these into the set. So our set is going to be equal to 1, 2, 3, 4. So this is the final set. Now in JavaScript or similar, I'm pretty sure there is not a data structure like this. So what can you do? So you can make an array, and then if number not already in array, push num in array, and finally sort array. And this should basically do the same thing. Okay, oh my god, what did I do? And this should basically do the same thing. So we're at the end, you're gonna be left with 1, 2, 3, and 4 for this case at the end. Okay, and if I'm gonna take a look at the code just to make sure that I'm not messing something up. Okay, so yeah. Okay, and finally we're going to run a for loop. We're going to run loop from 1 to n inclusive. Okay, and then if any of the if the number is not in the set, if the current from okay, let's say I is equal to 1, and then so this is basically going to be for each. Okay, so yeah, we're gonna run the loop, and if okay, so let's say from I equal to 1 to n equal to 4. Okay, this is gonna be our first case, and in the set we have 1, 2, 3, and 4. Okay, we have in this case we have all numbers from 1 to 4 inclusive. So we print positive answer. Okay, so we print the positive answer, which is this. We print this. Okay, that is what we do. Okay, but in our second case right here, which is case 2, in case 2 we have n is equal to 4 again, but the final set is going to be only 1, 2, and 3, or the final array. So the final set or array or whatever is going to be only 1, 2, and 3. And in this case, we do not have all numbers from 1 to n inclusive. So negative answer which is this right here, like this. And yeah, that is basically it for that one. And let's look at the code. No, bro has Python. Okay. Bro, I think your solution is of n login. I mean, I don't know. Like, this one, I think that this one is, okay, this one is, so this is definitely O of n, then this might be even n squared if I'm being honest. But it does work for this, but as I did get accepted with this. So, and I know this might not be the most optimal, this is probably not the optimal solution, but it's the one that I found. And as you guys know, I'm not a master. I'm just teaching you what I know and what I have able to, and how I have able to solve it. So, yeah, we get n, this is our levels. We get n, then we get the p, then we get the first p, then we get these three integers right here. So p is 3. We get these three integers. We put them into the set. Then we get p. This is the second p. So we get these two integers now. We put them into the set, and right now we have 1, 2, 3, and 4 into the set. And now we go from 1 to 4. And if any of these, if any of I is not in the set, we're going to print the negative answer and we're gonna return. Otherwise, when this loop is done and this has not executed, it means that all of the elements that we need are in the set, so we're gonna print a positive answer. Okay. No, yeah. Okay, guys. Okay, so yeah, I think that's it for, okay. And I already went through the negative case, so I don't think we need to go through that. So I'm just gonna delete all this and let's go to the next one. Okay, let's make this blue, and then we're okay. Now we have, okay, this is gonna teach, if you don't know this is gonna teach you something very useful, which is how to find all subsets of a set. That is something very useful. Okay, so here's a problem statement. So yeah, for this one, you guys need to be a little bit familiar with bit manipulation and bitwise operators and thinking. So that this is sum of all subsets XOR totals. The XOR total of an array is defined as the bitwise XOR of all its elements, or 0 if the array is empty. For example, XOR total of the array 2, 5, 6, 2 XOR 5 XOR 6 is equal to 1. Given an array nums, return the sum of all XOR totals for every subset of nums. Note, the subsets with the same elements should be counted multiple times as a subset of an array B if it can be obtained from by deleting possibly 0 of its elements. Okay, guys, so one, if you have basically not seen, if you so how does, so this is how XOR works. So maybe you're seeing this for the first time. So I'm gonna try to explain how this works. I'm gonna try to explain how this works. So here we have 2 and XOR 5. So 2 XOR 5, and this is basically the symbol for the XOR, which we also use in our code, like right here. I think you should look at editorial. Maybe tutorial solution is better, and then you may learn new approach or logic. Yeah, I'm probably gonna do that after the stream, man. I'm gonna do that after the stream. Okay, so basically this works. So 2 in binary is 1 0, and 5 in binary is 1 0 1. Okay, so and basically this the XORs the bits in the binary representation. So zero. So we want to keep in mind 0 XOR 1 is equal to 1, and 1 XOR 0 is equal to 0. But 0, and these are the bits right here, and 0 XOR 0, 0 is equal to 0, and 1 XOR and 1 XOR 1 is also equal to 0. Okay, so basically an easy way to remember this. Okay, well, oops, okay, this is not 0, this is 1. So every number, when you XOR any number with 0, that number becomes the number itself. So here we XOR 1 with 0, it's gonna be 1. And here we XOR 1 with 0 again, that's gonna be 1 again. It's gonna be 1 again. Another easier way to remember this is if odd, so this is an odd number of ones and zeros. If odd, it is 1, and if even, it is 0. Okay, so here we have 2 ones, 1 and 1, and basically 1 and 1 is 0. This is even. Here we have 2 zeros, so 2 is an even number, we get 0. Here we have an odd number of ones, so 1 1 and 1 0, this is 1. 1 0 and 1 1, this is 1. Okay, and basically what happens when we have 2 XOR 5 is we have this, and this 0 is because everything to the left is filled with zeros. Okay, and then to accommodate when doing this. Okay, so this is what happens. So these are the binary representations of 0, of 2, and 5. And what happens here is we have so 0 and 1, as we can see, is gonna give us 1. Okay, then 0 and 1 gives us 1. Then we have 0 and 1 again, it gives us 1 again. Then we have 0 and 1 again, it gives us 1 again. And this is 7 in decimal. This is 7 in decimal. Okay, all right, because how this works. So this is the first one is 1, because so this This right here gives us 1 because this is 2 to the power 0 times 1. This right here gives us 2 because this is 2 to the power 0 times 2. No, this is 2 to the power, this is 2 to the power 1, which is 2 times 1. So we have 1 and 2, which is 3. And then this is 2 to the power 2 times 1, which is 4. So we have 4 plus 2 plus 1, which gives us 7. Okay? And now that we have 7, so the result of 2 XOR 5 is 7. And then we have 7, and then we're going to have 7 XOR 6, which, as we have seen, 7 in binary is this, and 6 in binary is 110. Okay, what happened? 110, 111, 110, like this. So this is 7 in binary, this is 6 in binary, and we're gonna XOR this. Okay, we're gonna XOR this, if I can even put this there. Okay, so now we get 1 and 0, that is 1. Okay, as we can see here, 1 and 0 is 1. Then 1 and 1, it's even number, so that's an even number of 1, so we're gonna get 0. Then 1 and 1 is 0 again, and this right here is 1 in decimal. This is 1 in decimal. Okay, and as we can see in the problem statement as well, we have 1 here as well. So guys, I hope that at least you got some of that. I know maybe I'm not the best at explaining, but I hope you got some of that. So that is what we need to do. We need to keep track of the XOR sum, of the XOR total of every subset. Wait, I'm here. 10 likes completed. Wow, thank you guys so much for 10 likes. Yo, thank you guys so much for 10 likes. I love you guys. Thank you guys so much for 10 likes. I appreciate you guys so much. I appreciate you guys so much. Nice. Okay. So I explained that. Now, okay, so now we know that for each subset we want to get the XOR total of it. So for the empty subset, it's gonna have an XOR total of 0. The subset, which is 1, is gonna be an XOR total of 1. Then 3 is gonna be 3. 1 XOR 3 is 2. In the second test case, we can see the empty subset has a total of 0. Okay, so pretty sure. So what is a subset? A is a subset of B if A can be obtained from B by deleting some possible 0 elements of B. So the empty when we have nothing, it's a subset as well. So here we have 1. So we have here 1 and 3, and this is a subset. It has only 1. Then we have 3. So this is another subset with only 3. We have 3 here. And the last subset is 1 and 3 right here. And basically, the amount of subsets we can generate from an array is 2 to the power n, where n is the amount of elements inside of the array. So right here we have 2 elements, and we get 2 to the power n subsets. So we have 4 subsets. We have the empty subset, we have the empty one, we have this one, the third, and then this one is the fourth. Okay, and we get the subset sums of all the XOR totals of all the subsets, and it gives us 6. Here we have 3 elements, so we're gonna generate 2 to the power 3 subsets, which is 8 subsets, and we see here 8 subsets. Okay, and for each subset we get the XOR total. Okay, and here we have this many 1, 2, 3, 4, 5, 6 elements, which is gonna be 2 to the power 6 subsets. If we say 2 to the power 6, okay, wait a sec. Oh no, this is the XOR total. So this is the XOR total of all the subsets. So in this case, we're gonna have 2 to the power 1, 2, 3, 4, 5, 6 subsets, which is gonna be 64 subsets. Okay, subset this, subset that. But how do we actually get these subsets? Well, there's a couple ways. We can do it with recursion, but the way I'm gonna show you guys is with bit manipulation. So first, what do we do? So first we get how many subsets we are gonna get by left shifting 1 by n times. So here we have two numbers. So this nums.size, this is the length of the array. So the length of the array is 2. We're going to left shift 1 by 2. Okay? Okay, so I explained this. I'm gonna get rid of this. And then we're gonna copy this. Let's say current problem is this. Oops, okay. Okay, yeah, I'm gonna have to delete this. Try again. Make it where current problem is this. Okay. Problem is elite code. This one. Alright. So that's the current problem. Okay. I'm in high school, but I understood some things. I'm glad you were able to understand some things. Love you, bro. I love you too, man. I love you too, man. Thank you. I love you. Okay. So now we went through what a subset is. We went through what an XOR sum is. Okay, so now what is this thing? Why is this thing working? How is this giving us the total number of subsets? Why does this, when we left shift this, why do we get 4 in this case? So this is how this works. So when we have 1, so in this case our array is 1 and 4, and I think it's 1 and 3 actually. Okay, it's 1 and 3. It's 1 and 3. So our array is 1 and 3, and the length is equal to 2. So this is what this nums.size is going to give us. It's going to give the length of the array, which in this case is 2. Okay, and then we're going to say 1 left shift by 2. Now this might be very confusing if you're seeing this for the first time. So basically in binary 1 is equal to 1, like this, and of course it has many zeros to the left, because basically computers store integers in binary, and they have all of these. For example, in a 32-bit integer inside of C++, in a 32-bit integer, there are 32 bits in total. So we have basically 1, and then we have 31 bits to the left of this integer 1, but I'm not gonna write all of them. So basically 1 in binary is roughly 1. And when we say left shift by 2, basically we're going to add 2 zeros at the end of 1, like this. When we left shift 1 by 2, we are basically adding two zeros at the end of one in binary, okay, in the binary number system. So and now we get a new number, so just one. So this is equal to, so this right here, so this right here, this one right here, this is binary. So how do we convert binary to decimal? Well, first we have 2 to the power 0 right here. Okay, first we have 2 to the power 0. So this is 2 to the power 0, which is equal to 1. Okay, so to convert from binary to decimal, basically we have to multiply each of these binary digits or bits by 2 to the power of their position. So the position of this is 0, the position of this is 1, and the position of this is 2. So right now we have 2 to the power 0. Next we're gonna have 2 to the power 1, okay, because this bit right here is the first bit, so we're gonna have 2 to the power 1, and finally we're gonna have 2 to the power 2, okay, because this right here is the second bit from 0, 1, 2, okay, and then we're going to multiply, so we're going to multiply 0 times 2 to the power 0 plus 0 times 2 to the power 1 plus 1 times 2 to the power 2. So let me make this a little bigger. Let's say 36 or something. And how much is this gonna give us? Well, it's gonna give us the following. So 0 times, it doesn't matter, 0 times whatever is 0. So that's 0 plus 0 times 2 to the power 1 is also 0. Is also 0. Okay? And finally, this is 1 times 2 to the power 2, which is, we know, is 4. And this is going to give us 4 in the end in decimal. And that is how we got that the total number, which is also total number of subsets of set of size 2. Okay, so this array or set is of size 2, and the total number of subsets is 2 to the power n, which is 2. So total number of subsets is 2 to the power 2, which is the length of array. Okay, guys, that's that. Okay, so okay, so how do we actually get these subsets? Okay, so this is how we get the subsets with bitwise. So first we're going to have 0. Okay, so we're going to, as we can see right here, so this is going to keep track of our total answer, so the sum of all the subsets, the XOR totals. So we're going to have, this is all the subsets, so we're going to iterate from 0 until so we're going to iterate through all of the numbers from 0 to 3, and it says in our case n is equal to 4. Then I'm gonna keep track of this I'm gonna put it in J. Here we're gonna have our XOR total for that current subset. So while J, basically while J is not 0, so if J is 1, for example, where it's 1, we are going to check each bit. So J and 1, this is going to give us the last bit, the last set bit, as we can see here. using bit manipulation on Geeks for Geeks. This approach is simpler compared to backtracking, just requires basic knowledge of bits. So each element in an array has only two choices. It can either be included or excluded from a subset. We can represent these choices using bits. 0 means included and 1 means 0 means excluded and 1 means included. The ith bit corresponds to the ith element of the array. So basically, for an array of size n, there are 2 to the n possible subsets, which I already told you guys, and each subset can be uniquely represented by the bit representation of numbers from 0 to 2 to the n minus 1. And that is why we are looping from 0 to 2 to the n minus 1, which is 3. Okay? So for an example, if we have an array AB, which is very similar to what we have in our case, we have 1 and 3. So the empty subset A and B excluded is going to be empty, okay, like in our case. So at first J is going to be equal to 0. So J is 0. This gives false because this is 0. If it was a positive number, it would have went inside of the loop. But since J right now is 0, this is not going to execute. Then we add 0 to the answer, okay? So now we're on the next iteration. Now J is equal to 1. J is equal to 1 in decimal. And in binary, 1 is 0, 1. So we're going to include, basically, we are going to include the element which is on index this one. So basically how this works, so we start from index 0, okay, and if the current bit is set, we are going to add to the index, we're going to add that index. So right now the bit is set, so we're going to add 1 to the subset. Basically we're going to add 1 to the XOR total, okay. Then we do index plus plus. So then we right shift. This basically, so we saw that once by left shifting, the number gets added zeros to the end, and when we right shift, for example, this by 1, this is going to make 1 0. We remove the last bit, okay, and it gets shifted to the right. Okay, and then we increment the index. Now J will become 0, so we go out. So and then we get the first subset XOR total, which is 1, and we add it to the answer. Then I becomes 2, so it becomes 1 0. So the binary representation of it is 1 0 right here. So if then we set this is equal to 2 and or 1 0 in binary, and as we can see right now, so we have J is equal to 1 0 in binary. So this checks 1 0 and 0 1 0 1, so this gives 0. Because 1 and 0 is 0 and 0 and 1 is 0. This gives 0. So it's not going to go inside this loop, but it is going to increment the index. So now index is equal to 1. Okay? And then it is going to right shift J by 1. So now J is equal to 1 in binary. Okay? So then J equals to 1 in binary. Then it's going to be 1 and 1. Right here, which is equal to 1, so it's going to go inside, and then we're going to XOR equal with nums of index, which nums it is nums of 1, which is equal to 3. Okay, and that is how we get the third XOR total. Okay, and then for the final XOR total of this case, we J becomes final for this case. J equal to 3 or 0 1 1 or 1 1 in binary. Okay, Alright, and that is how we get 1 and 3. So right now j is 1 1. Okay, let's remove this to not get confused. So we're gonna say 1 1. So basically we're gonna say 1 1 and 0 1, 1 1 and 1. Okay, which is going to be equal to 1, and we're gonna come in here, and now we're going to add 1 to the XOR total. So right now the XOR total is equal to 1. Okay, since this is nums of 0, since index is equal to 0 and this is 1, so we're gonna put nums of 0. Then we have index plus plus, this is gonna become 2. Actually it's gonna become 1, and then j is gonna become, so right now it's 1 1, yeah, it's gonna become 1. So then we're on the last iteration of this. Now j and 1, yes, because it's 1 and 1. Now XOR total is going to be equal to 1 XOR 3, which is equal to 2. So the index is 1. So this is nums of 1, which is 3, which we XORed our previous XOR total, which is 1, with 3, and that becomes 2. Okay, so then we have index plus plus again. We right shift, and then j becomes 0. This terminates the loop. We add the answer, the XOR total to answer, and that is basically, that was the last iteration of the for loop. We go out and we return the answer, which is basically 0 plus 1 plus 3 plus 2, and that is 6, and that's basically it for that one. Okay guys, so we already went past the 1 hour mark. Thank you so much for joining, for everyone who joined today. Thank you for subscribing. And thank you to everyone who liked and subscribed. Thank you guys so much for joining, and I will see you guys tomorrow. Until then, have a good one.